This is lesson 5.3, solving systems by elimination. Your objective is that you can solve a system of equations using elimination. Alright, so this is a pretty almost a fun way of being able to solve those systems, especially if it kind of works out. I find a lot of students really like this method if it works out, and they can sometimes get frustrated if it doesn't. So know that you always have all three of these available to you. So let's go ahead and get started, and we'll kind of get it as we go. So number one says, okay, x minus 3y equals 2, and negative x plus 2y equals negative 3. Now, hopefully the name kind of gives it away of what we're trying to do here is we're trying to make it so that it eliminates. And this is a really kind of cool concept in the way that it actually kind of works. And one key thing is that is a y. So whenever we're doing solving, whenever we're solving by elimination, what we want is we want it so that whenever we add things up, they wind up being 0. And specifically, we only want one thing to become 0 if possible. And we can kind of manipulate these in order to do that. The big key idea, though, that you need to know is everything has to be lined up. So what I mean by that is if I had x plus y equals 4, and I had y minus x equals 2, this doesn't quite work. We need to adjust it so that then the x's are all in the same column. The y's are all in the same column. You kind of want that equals all in the same column. And then we want you can have your numbers all in the same column. So you want everything to be in its own column. In this case, it actually is already set up like this. So what I'm going to do is I'm going to actually draw these kind of invisible columns between each one, just so I can know that everything's separated out. And so what we have here is we kind of have, you can almost imagine these being their own separate equations. So what we do is we actually add the top and the bottom. So x plus negative x gives us 0x. And also in this one, kind of keep everything, again, in its own separate area. Negative 3y plus 2y is negative 1y. 2 plus negative 3 is negative 1. And we still have that equal sign. And now, and I'm able to do it pretty easily on mine, you don't need to necessarily do it on yours. We now have everything lined up. And so we can rewrite this as negative 1y equals negative 1. We divide everything by negative 1. And we get y equals 1. And you might be slightly confused right now of how that works, and we can go in with this one. This one's pretty easy to do it with. We'll go in and we can actually show how do you do this by substitution. Now we kind of go back in the ways that we used to do with substitution, and we plug in for y. So I get x minus 3y equals 2. I guess I can circle this in black so that we can see where it comes from. So x minus 3, this is a 1, equals 2. So I get x minus 3 equals 2. I add 3 to both sides. And I get x equals 5. Now what we're going to do is we're going to go in and we're going to check this, like the normal check that we've been doing before. So with the check, what we're doing is we're going to plug in 5, 1 for everything. So this is my x, this is my y, just keeping that in mind. So let's start with the first one. So x minus 3y equals 2. Now if this works, both of them should have the same answer. So I have 5 minus 3 times 1 equals 2. So I go 5 minus 3 equals 2. 5 minus 3 is 2. 2 equals 2. Okay, cool. It works on the first one. Let's check the second one. So I have negative x plus 2y equals negative 3. So I go negative 5 plus 2 times 1 equals negative 3. Negative 5 plus 2 equals negative 3. Negative 5 plus 2 is negative 3, so negative 3 equals negative 3. Hey, it works out. It does work. Now, if you didn't see that, that's totally fine. Like I said, you can always use substitution. So if I had this, and you don't necessarily need to write this part down, but it's good to see, yeah, you can actually use both methods. If I was looking at this, I'd say, hey, I could get x by itself really easily up on the top. So I'd say, okay, x minus 3y equals 2. Add 3y to both sides. I get x equals 2 plus 3y. Now I take it and substitute it in, so I have negative 2 plus 3y plus 2y equals negative 3. Distribute the negatives. Negative 3, combining like terms, so negative 2 minus 1y equals negative 3. Add 2 to both sides. I get negative 1y equals negative 1. Divide by negative 1. Oops, that's a 1. 1, that's a 1, not a 4. 1. And I get y equals 1. Same thing, and then we'd plug it in like we did there. So it works both ways. If you don't see the elimination, that's totally fine. Go ahead and use substitution. Let's look at number 2. And that's going to be the last time I'd use substitution, unless it's just straight easier. So 4x plus y equals 5. 3x, oops, this is a minus y, apologies. This is a minus y right here. Plus y equals 9. Now the nice thing with some of these is they're already arranged in a way that makes it so that you can almost kind of see that elimination easier. Some people like to put an equal sign underneath it and like throw a little plus out here, and that's totally fine as well if that helps you kind of imagine it. I'm going to make my columns. And so I get 7x, because I'm going 4 plus 3 is 7. Negative 1 plus positive 1 is 0, so 0y. 5 plus 9 is 14. I have an equal sign in here. So if I were to rewrite this, I get rid of the y's, so I'm left with 7x equals 14. And so I get x equals 2. Now I can plug this to into either of the equations. So I'm going to say, okay, I'm just going to do the top one. Doesn't really matter which one you do. 4x minus y equals 5. Let's circle this in black. So I get 4 times 2 minus y equals 5. 4 times 2 is 8, minus y equals 5. Subtract 8, I get negative y equals negative 3. Remember, you need to get rid of this negative, so we're going to divide both sides by negative. We get y equals 3. So my answer should be 2, 3. Now I'm going to plug these into both equations. This is my check. So 4x minus y equals 5. So 4 times 2 minus 3 equals 5. So I get 8 minus 3 equals 5. 5 equals 5. Hey, that one works. Awesome. Now let's check the other one. 3x plus y equals 9. 3 times 2 plus 3 equals 9. 3 times 2 is 6. Plus 3 equals 9. 9 equals 9. Awesome. Yes, it works. Okay, let's look at the next one. Number 3. 2x minus 5y equals negative 7. Negative 2x plus 3y equals 1. A question you should kind of like to ask yourself is, all right, which one am I solving for? Am I solving for x or am I solving for y? And you should be able to answer that as you look at it and you say, okay. And where that might be helpful is later on, there will be times where it doesn't work out, and we actually have little tricks in order to make it so that works. So you can imagine your columns, you're adding everything together. So 2x minus or plus negative 2x is 0x. Negative 5y plus positive 3y makes negative 2y. Negative 7 plus 1 is negative 6, negative 6. Okay, rewrite it again. So negative 2y equals negative 6. Divide by sides by negative 2. You get y equals 3. Now we're going to go in and we're going to plug that into an equation. So I'm going to say 2x minus 5y equals negative 7. I'm plugging in for 3, so I get 2x minus 5. Oops, I guess I should circle that. 3 equals negative 7. So 2x minus, or negative 5 times 3 is negative 15 equals negative 7. Add 15 to both sides. 2x equals negative 7 plus 15 is 8. Divide both sides by 2. We get x equals 4. So my answer should be 4, 3. We're going to plug those in. So 2x minus 5y equals negative 7. So 2 times 4 minus 5 times 3 is negative 7. 2 times 4 is 8. Negative 5 times 3 is negative 15. It's negative 7. 8 minus 15 is negative 7, so negative 7 equals negative 7. Awesome, that one works out. I'm going to try the other one. Negative 2x plus 3y equals 1. So negative 2 times 4 plus 3 times 3 equals 1. Negative 2 times 4 is negative 8. 3 times 3 is 9. Negative 8 plus 9 is 1. That equals 1. Awesome, it works out. Hopefully you're starting to kind of get the hang of this. If not, that's also fine. Let's do number 4. Negative x plus y equals 9. X plus 2y equals 6. Again, you can imagine those columns. We're adding each thing up. So negative x plus x, or negative 1 plus 1 is 0 x's. 1 plus 2 is 3y's, positive 3y's. 9 plus 6 is 15. So rewrite this, 3y equals 15. Divide by 3, y equals 5. Plug that into one of the equations. So let's say negative x plus, and in black, just so we can see it, 5 equals 9. So negative x plus 5 equals 9. Subtract 5 from both sides. I get negative x equals 4. Remember, you need to get x alone, so we divide by that negative, or the negative 1 if you need to. X equals negative 4. So my answer should be negative 4, 5. Well, let's check it. So if I have negative x plus y equals 9, plug in everything. So -4 plus, parentheses, 5 equals 9. -4 makes +4 plus 5 equals 9. 4 plus 5 is 9. 9 equals 9. That's true. Let's check the other one. X plus 2y equals 6. So -4 plus 2 times 5 equals 6. So -4 plus 10 equals 6. -4 plus 10 is 6 equals 6. It's a true statement. Alright, if you think you're getting this, go ahead and try this number 5 out on your own and then resume. See how you do, see if you get it. If you get stuck, go ahead and watch through this. 5x plus 3y equals 12. So again, checking and looking, hey, something's going to cancel out, right? Yeah, this cancels out. So we're going to go ahead and add these together. So we get 7x plus 0y. 9 plus 12 is 21. So we get 7x equals 21. Divide by 7, divide by 7. X equals 3. Plug that into one of the equations. So 2 in black. 3 minus 3y equals 9. 2 times 3 is 6. Minus 3y equals 9. Subtract 6. So -3y equals 3. Divide by -3. Y equals -1. So my answer should be 3, -1. Plug those in. So 2 times 3 minus 3 times -1 is supposed to equal 9. Oops, I guess I'll write this above there, just in case you're looking at it. So 2 times 3 is 6. -3 times -1 is +3 equals 9. 6 plus 3 is 9 equals 9. That one checks out. 5 times 3 plus 3 times -1 equals 12. 5 times 3 is 15. +3 times -1 is -3 equals 12. 12 equals 12. That one works out. Again, if you think you're getting it, go ahead on this one, take a pause, try it on your own. Even if you're not getting it, go ahead and pause it and try it on your own. See if you can get it. See if you're kind of messing up a little spot. And it's a really great opportunity for you to say, okay, how am I doing this? Can I get it right? And maybe you'll find out where you're kind of messing up and you can ask your teacher for a little more assistance. Alright, so right now, go ahead and pause it, try it out for just a little bit, see how far you can get. Alright, hopefully you got it. If not, we'll go ahead and run through this. So, what's being canceled out? The x's are being canceled because I have a -4 and +4. I'm going to add these together, so I get 0x. -1 plus 4 is +3y. 11 plus -20 equals -9. 3y equals -9. Divide everything by 3. I get y equals -3. Now I'm going to plug that in, so I get -4x minus -3 equals 11. -4x plus 3 equals 11. Subtract 3 from both sides. I I get negative 4x equals negative 8, or positive 8, sorry. Divide by negative 4, divide by negative 4, x equals negative 2. So my answer should be negative 2 comma negative 3. Let's try it out. Negative 4 times negative 2, oops, negative 4x minus y equals 11. Okay. Minus negative 3 needs to equal 11. Negative 4 times negative 2 is positive 8. Negative minus negative 3. Negative times a negative is a positive, so that makes a positive 3 equals 11. 8 plus 3 is 11, and equals 11. Let's try the other one. The 4x plus 4y equals negative 20. So I do 4 times negative 2 plus 4 times negative 3, and that's supposed to equal negative 20. 4 times negative 2 is negative 8. 4 times negative 3 is negative 12. That equals negative 20. Combine like terms. Negative 20 equals negative 20. That works out. Okay. All right. Number 7. This is where it starts getting a little more tricky. The reason why is once I write this out, x plus y equals 7, and 5x plus 2y equals 8. Here's the question. What's getting eliminated? In this, nothing is expressly being eliminated. And so we need to alter the entire, we need to alter some stuff to make it so that then something is going to get eliminated. You can choose either your x or your y. It doesn't really matter which one. Me looking at this, I kind of want to eliminate the y. The reason why is, you'll see here in a second, but I see this 2 and I see this 1, and I know that's going to be a lot easier thing to kind of meet up with. The way that we do this is we actually can multiply the top, the bottom, or both. And we can multiply by positives and negatives. We can multiply by just about anything except for like 0, and I would probably recommend not doing fractions or decimals. So what we can do is we can say, hey, I want to eliminate y. I want to eliminate y. And you could say x if you wanted to, but I'm going to choose y. Now I have to look at those. I have a y and I have a positive 2y. The way that I eliminate those is I need them to be kind of opposites of each other. So the opposite of 2 is negative 2. So what I wind up doing is I multiply this entire top, and maybe let me do this in a different color. That way you can kind of see that happening. I multiply this entire top by negative 2. Now invisibly, and the reason I'm putting this here is just so that you kind of have it as a reference, I'm also multiplying the bottom by 1. And you can actually almost see that this is a 1. And so one of them is the opposite and one of them is kind of the same. So when I rewrite this, let me just choose another color. I have x, negative 2x, minus 2y equals negative 14. And I have 5x plus 2y equals 8. So now I can start solving this, and I can see right here, I'll even switch the number color again, these y's are being eliminated. So I can go ahead and write this out. So I get 3x plus 0y equals negative 6. So if I rewrite this, 3x equals negative 6, divide everything by 3, I get x equals negative 2. Now, where some people kind of, what I really recommend on this is don't use this equation. Don't use these, the new purple ones. We're going to go back to green, and we're going to plug stuff in. And I guess I'll put purple on for this one, for this little part. So I have -2 plus y equals 7. And the reason for this is just in case you'd made some kind of mathematical error in the purple, you'll be able to catch it a lot easier if you go back to your original equations. And that way you know that it actually works in the original equations. So I'm going to add 2 to both sides. So y equals 9. So my answer, hopefully, is -2, 9. So now I'm going to plug these in. So I'm going to start with the first one. So x plus y equals 7. So -2 plus 9 equals 7. -2 plus 9 is 7. 7 equals 7. All right, cool. That part works. Now for kind of the real check, 5 times -2 plus 2 times 9 needs to equal 8. That is a really bad 8. There you go. So 5 times -2 is -10. Plus 2 times 9 is 18, and that needs to equal 8. -10 plus 18 is 8, and that equals 8. Hey, it works out. Cool. Okay. Let's do number 8. 7x minus 6y equals 9. 5x plus 2y equals 19. Now the question that we have is what's being eliminated? And I look at it and I say, well, there's nothing being eliminated. Again, in this case, I'm going to choose the y's. The reason I'm choosing the y's is because it has this negative and this positive already. Those are already built in, quote unquote built in. And so that gives me something that I can work with. I can say, hey, yeah, this might work out and I'm not going to have to do much. So I kind of off to the side, I'm going to say, all right, eliminate the y's. I have a 2 and I have a -6. How do I make it so that these cancel out? I need to multiply this by 3. This I don't multiply by anything. You can write that times 1 there if that helps you a little bit. So I'm going to multiply this whole bottom by 3. All right. So let's write this in purple just to indicate that we're kind of talking about a new set. So 7x minus 6y equals 9. And remember, we actually technically just multiplied this by 1. And so we get 3 times 5 is 15x, plus 3 times 2 is 6y. 3 times 19, probably not something that you know off the top of your head. 3 times 20 of those should be pretty easy. That's 60, and then we just take 3 off of that, so we get 57. Now I check, are my y's going to get eliminated? Yes, they are, so I'm going to go ahead and continue. So 7 plus 15 is 22x plus 0y equals 9 plus 57, that winds up being 66. So I get 22x equals 66 divided by 22. That's 22. And I get x equals 3. Now I'm going to plug these into the original equation, or this x into an original equation. And you get to choose whichever one you want to do. I'm going to do the top one just because that's the pattern that I've been doing. So I go 7 times 3 minus 6y equals 9. So 7 times 3 is 21 minus 6y equals 9. Subtract 21 from both sides. So negative 6y equals, what was that, negative 12? Divide by negative 6, divide by negative 6, and y equals 2. So hopefully my answer should be 3, 2. Now I'm going to plug these in. Check. So 7x minus 6y equals 9. 7 times 3 minus 6 times 2 equals 9. 7 times 3 is 21 minus 12 equals 9. 21 minus 12 is 9 equals 9. Awesome. I'm going to check the other one. 5x plus 2y equals 19. So 5 times 3 plus 2 times 2 needs to equal 19. 5 times 3 is 15. 2 times 2 is 4. And that equals 19. 15 plus 4, 19. And that equals 19. Awesome. Okay. Let's do, what was that? That was number 8. Let's do number 9. 2x minus 7y equals 5. X minus y equals 10. What's being eliminated? Currently nothing. So let's eliminate. I'm going to look at this one. I'm going to say, hey, these x's are really close. These y's are kind of far apart, and they're like both the same sign. I mean, both of them are both the same sign, but they're both kind of, this 2 and the 1 are a lot easier too. So let's eliminate x. So I have a 2x and I have a 1. I'm going to keep the 2x as it is. So I'm going to just multiply it by 1, and I'm going to multiply this one by negative 2. So negative 2, this one by 1. So now we have some new stuff. So we got 2x minus 7y equals 5. Negative 2x plus 2y equals negative 20. Okay, the x's are going to cancel out, so this is going to work out for us. So we get 0x minus 5y equals negative 15. So I get negative 5y equals negative 15. So my y, divide by negative 5, divide by negative 5, my y equals 3. I'm going to plug this into one of the original equation. Looking at this, I think my better choice is going to be the bottom one, so I'm going to go x minus 3 equals 10. So I get x minus 3 equals 10, so I add 3 to both sides. I get x equals 13. So 13, comma 3. Now I'm going to check them. So I go 2x minus 7y equals 5. 2 times 13 minus 7 times 3 equals 5. 2 times 13 winds up being 26. 7 times 3 is 21. 26 minus 21 is 5. Plug it into the other one, which says x minus y needs to equal 10. So I put in 13 minus 3 needs to equal 10. 13 minus 3 equals 10. 10 equals 10. Awesome. Okay. Alright, number 10. This one's slightly different. 3x plus 4y equals negative 1. And negative 2x minus 5y equals 10. The reason this one's a little bit different is because we're not just going to meet up. We're not going to take 1 up to the other. So we're not going to take this 2 up to the negative 3. We're actually going to find the least common multiple, LCM. You might remember this from before. If not, totally fine. Basically what we're looking for is where do 2 and 3 meet for the first time? Or 4 and 5. Looking at this, just kind of knowing my multiplication numbers, I'm actually going to choose the x's. So I'm going to eliminate x. So I have 3x and I have negative 2x. And what I want them to be is I want them to be kind of two different things. The easiest way, quote unquote, to kind of do this is to just kind of multiply by like the absolute values of each other, so that then they wind up being at the same place. So I'm going to multiply this one by 2 and this one by 3. And what that does is 3 times 2 is 6x. We're going to wind up at 6x and negative 6x. So let's show that. Oh, I'll change this one. So we're going to multiply by the 3 one by 2 and the 2 one by 3. So what I wind up having is 6x plus 8y equals negative 2. And I distribute that 3 out throughout all of it. So I get negative 6x minus 15y equals 30. Now I can solve. Combining like terms, I look at this and I say, yep, these x's are canceling out, so I'm going to get 0x. 8y minus 15y is negative 7y. And that equals negative 2 plus 30 is 28. So I get negative 7y equals 28. Divide by negative 7, divide by negative 7. So my y equals negative 4. Now I'm going to plug that into an original equation. So I'm going to choose the top one. No particular reason, just because I feel like it. 3x plus 4 times negative 4 equals negative 1. So I get 3x minus 16 equals negative 1. I'm going to add 16 to both sides. So 3x equals 15. Divide by 3, divide by 3, x equals 5. So my answer should be 5 comma negative 4. We'll try it. So we have 3 times 5 plus 4 times negative 4 equals 1. So I get 15 minus 16, oh, that should be a negative 1, equals negative 1. Negative 1 equals negative 1. That checks out. Then I have negative 2x minus 5y equals 10. So negative 2 times 5 minus 5 times negative 4 equals 10. Negative 2 times 5 is negative 10. Negative 5 times negative 4 is positive 20. That is equal 10. Negative 10 plus 20 is 10, and that equals 10. Alright, go ahead and try number 11 on your own real quick. I'll be continuing on once I kind of write it out, just so you don't have to sit through me pausing for a while. So negative 5x plus 12y equals 8. 2x minus 8y equals 0. So go ahead and give this video a pause. Go ahead and try it on your own, see how you can do. I am going to continue on though. Alright, so looking at this, I get to make a decision. Am I going to try and solve for x's or eliminate x's or eliminate y's? I'm going to eliminate the x's. Doesn't really matter which one, you could do either way. So I have negative 5x, and I have 2x. Looking at this, I want to make this 10, so I'm going to multiply this by 2, multiply this by 5. So I get negative 10x plus 24y equals 16. And I get 10x minus 40y equals 0. Combine like term, or add everything up. I wind up with negative 16y equals 16. Divide by negative 16. Y equals negative 1. And I'm going to plug that into one of the original equations. Negative 5x plus 12, oops, purple, negative 1 equals 8. Negative 5x minus 12 equals 8. Add 12 to both sides. Get negative 5x equals 20. Divide by negative 5. X equals negative 4. So my answer should be negative 4 comma negative 1. Now what we need to do, we need to check. So negative 5x plus 12y equals 8. Negative 5 times negative 4 plus 12 times negative 1 equals 8. Negative 5 times negative 4 is positive 20. 12 times negative 1 is negative 12. 20 minus 12 is 8. That equals 8. Yay. 2x minus 8y equals 0. 2 negative 4 minus 8 times negative 1 equals 0. 2 times negative 4 is negative 8. Negative 8 times negative 1 is positive 8. Negative 8 plus 8 equals 0. 0 equals 0. Woohoo. Okay. Number 12. Negative 10x plus 3y equals negative 30. 15x minus 8y equals 45. So again, I can ask myself, what do I want to try to eliminate? Looking at this, you can do 3 and 8 make 24, or 3 and 2 and make 30s. So I'm going to choose the x's. You could choose the y's if you wanted to. It's not going to change pretty much anything. You're going to get the same answer. So I'm eliminate the x's. So I have a negative 10x and I have a 15x. Those kind of meet for the first time, quote unquote meet, at 30. So I'm going to multiply this by 3 times 3 and multiply this times 2. So I'm going to do this times 3, this times 2. Oops. Alright, so I'm going to write these out. So I get negative 30x plus 9y equals negative 90. Then do the bottom row. 2 times 15 is 30x. 2 times 8, negative 8 is negative 16y. 2 times 45 is 90. So I get negative 7y, oops, 0x minus 7y equals 0. So negative 7y equals 0 divided by negative 7. And y equals 0. And that's totally fine. That can happen. Just kind of makes our lives a little bit easier, really. So now I'm going to plug this in. So I'm going to go negative 10x plus 3 times 0 equals negative 30. So I get negative 10x. 3 times 0 is 0 equals negative 30 divided by negative 10. I get x equals 3. So my answer should be 3, 0. So we're going to check those. So negative 10 times 3, oops, well, 3 times 0 equals negative 30. Negative 10 times 3 is negative 30, plus 0 equals negative 30. Negative 30 equals negative 30. Yay! Now let's do the other one, which is 15x minus 8y equals 45. So 15 times 3 minus 8 times 0 used to equal 45. 15 times 3 is 45. Negative 8 times 0 is 0, so you can do a minus 0 or plus 0, doesn't really matter. You get 45. 45 equals 45. Awesome. Alright, one last problem before you guys go off on your own. This is number 13. And this is a word problem. Word problems are the most kind of realistic problems because that's what you're going to encounter. So, you and your friend are buying throw blankets with your names embroidered on them. The cost of the throw blanket is X dollars and the cost of each embroidered letter is Y dollars. Your name has 6 letters and the total cost is $29. Your friend's name has 3 letters and the total cost is $24.50. Find the cost of the throw blankets and the cost of each embroidered pillow. So, a couple of things that we know. So a blanket is going to be our X, and a letter is going to be a Y. We don't know how much each one is, or how much X is, or how much Y is. So, what we do know is your name, I'm just going to say my name, is 6 letters. Your friend has 3 letters. We're only buying one blanket, so, you know that my name is 6 letters and is $29. We know your friend's name has 3 letters and is $24.50. So in setting this up, we know that we each got 1 blanket. So we're going to have 2 equations. So maybe I write like a little symbol next to this as like my problem and the friend's, or my blanket and the friend blanket. So x plus, we have 6 times the cost of each letter, so 6y. And we know that equals 29. Our friends need 3 letters, and that costs them $24.50. Now, the question is, when we have a system like this, how do you want to solve it? So you can use either way. You can use substitution or you could use elimination. I'm going to use elimination real quick. So I'm going to say, all right, I want to eliminate, and looking at this, the easiest thing to eliminate is going to be an x. And so I can arbitrarily, because I have these 2 x's, I can arbitrarily just multiply one by a negative. However, I'm going to be a little smart about it and say, I like working with positive numbers. I don't really like having negative numbers. So I'm going to multiply this bottom one by the negative 1, and the top one just by 1. So I say x plus 6y equals 29. And then I have negative x minus 3y equals negative 24.50. The x's are going to cancel out. Awesome. So I go 6y minus 3y, and this gives me 3y equals 29 minus 24 is a positive $4.50. Going to divide both parts by 3. So my y equals 1.50. And if you had to use a calculator right here, that's totally fine. The way I look at it is there's a 45 there and 15 minutes. So, all right. Now we're going to plug that into one of the original equations. Doesn't really matter which equation you plug it into. So I'm going to go x plus 6 times 1.50 equals 29. So I get x plus, what is that going to be? 9. Let me just double check. Yeah, 9. Okay. Then I'm going to subtract 9 from both sides, and I get x equals 20. So 20 comma 1.50. And now we check. So I go 20 plus 6 times 1.50 equals 29. 20 plus 9 equals 29. 29 equals 29. All right. Then we do x plus 3y equals 24.50. So my x is 20 plus 3 times 1.50. 20 plus 3 times 1.5 is 4.5. 24.50. Add those together, and we get 24.50 equals 24.50. Awesome. Go ahead and on your own, get going on your assignment from your teacher.